This is the saturated absorption spectroscopy setup. We use the secondary beam from the laser. It going through a polarizer and a iris. The polarizer is used to set the beam intensity. The iris is used to regulate the beam shape and size. Then the beam hits this thick glass plate. 2 weak probe is reflected from the front and back surface of this plate. Both of them going through this vapor cell, rubidium vapor cell. One strong pump is transmitted through and hits this mirror, and then this mirror, then bounce back also through this rubidium vapor cell. We need to make the strong pump co-propagate with one of the probe beam. To check that, we look at first here. If I block and unblock the pump, you can see the left spot are flushing. That means the strong pump and the left probe are overlapping here. Also, we need to check another point. Let's say here. Also, when I block and unblock, the left spot are flashing, which means they also overlap here. This means the strong pump and the left probe are perfectly counterpropagate. This thin glass plate is used to reflect the two probe to this bug eye detector. There are 2 detectors. Each one detect one of the probe beam. It's a differential detector, which means the 2 probe, each of them create a Doppler absorption well, and then the strong pump burns a hole into one of the probe beam spectrum by counterpropagating. By subtract the other probe beam, you can eliminate the Doppler well, which the only thing left is Doppler-free hole burned spectrum. Let's look at the resonance in the vapor cell. As I tune the horizontal knob of the diffraction grating, you can see there is a fluorescence signal, fluorescence flash by. Our goal is to use the horizontal knob and the current to search for the strongest fluorescence signal. This means you are sitting at the atomic resonance. Your laser is on resonance with one of the atomic resonance transition. And then we also apply a signal, a voltage, a ramp to the piezo, which oscillates the horizontal knob of the diffraction grating in a very fine way. This will give you a frequency varied spectrum of the rubidium atom.